Okay, so we're starting the next chapter. So we're looking at identifying and sketching related functions. Okay, so the place we're going to start is we know from National 5, reminder, that if I take a sine graph, so we know if that one there is y equals sine x, we know that that's 1, that's 0, and then down here is minus 1. We know that this is 180. We know that this is 360. We know the halfway in between bits as well. Yeah? That should all just be a wee reminder from National 5. But we also know that if I was going to draw that same graph, but a bit bigger. So if that maximum there was 3, then our minimum was minus 3. Still, we need to know what it is. We've still got 360 here. So we know that that is in fact y equals 3 sine x. Okay? And that's our amplitude. And this is the same for every single graph, every function. And we can generalize that for a function. So if we've got y is equal to some a amplitude times a function, any function, could be sine x, could be cos x, could be x squared, that what has happened is that it's stretched in the vertical axis. Okay, so it's stretched by a in the vertical axis. So if you think about the coordinates, if you've got the original coordinates x and y, they're going to become x and then a times y, because the y coordinates become a times bigger or a times smaller if it's a decimal. Okay? So that's our first one that we need to know. We're going through all of these that we've done before, National 5, but we're going to have a wee reminder of them. So the other one we can do is we could start our graph, and instead of, it's just going to look the same. We've still got our 1 up here, and we've still got down here our minus 1. But instead of having 360 here, I've only got 180. And here, I've got 90. Okay? So the way that we think about that is this changes something. It's not the amplitude, still sine, but it's into here. It's the number of cycles that we have. So how many waves there are in 360. So for this one, we're going to have 2 waves in 360, because if we've got 1 in 180, it'd be 2 in 360. Okay? So, to generalize that, so if we've got y is equal to the function of ax, so we've kind of multiplied the x part of our thing. So it could be that we've got sine or cos, and again it can still go into quadratics and all different kind of functions we've got. We can squish them. Okay, so what's happening this time is that they're either being compressed or stretched, or compressed, but this time it's in the horizontal axis. Because it's across the way. So we start with an x and a y again. This time, nothing's happened to our y coordinate, it stayed the same, but what's happened to our x coordinate is that it's been divided by that multiple. That's why 2x makes our x coordinates smaller, doesn't it? Because if we look at this one, we know that this is 2x sine of 2x, but our x coordinate compared with our normal graph has been halved, so we've divided it by 2. Okay? Okay, so the other one we should be really comfortable with from National 5 is where we have a sine wave that looks like this, where our maximum is up at 5, this is 4, then our minimum is at 3. But still, this here is at 360 this time. And so it's at 4, down here at 180. Okay, so we can see that the wave is shaped exactly the same. Its shape is exactly the same as our first graph. Okay? All that's changed is instead of starting at 0, it's now starting at 4. So what we've done is we've shifted the graph up or down. This time we've shifted it up, but we will be shifting them down in a wee bit. So this is y equals sine x, because the values are the same. It still goes up from our start. It still goes up 1, down 1, down 1, back up 1. See, it's still up 1, down to the same, down 1, back up 1. So it's still sine x, but what's happened is instead of being at 0 at the start, down here, it's now up at 4. So we've moved it up 4, or we've moved it 4 in the positive direction. So we've done y equals sine x plus 4. So the general one for this, so this is again for any function, if we have y equals f of x plus some constant c, all that happens is that it's moved, the whole graph is moved up or down, and then this time it is vertically. Okay, so it's moved up and down vertically. Depends, if it's plus, it moves up, if it's minus, it moves down. Okay, so any x and y coordinate becomes, the x coordinate doesn't change, and then it becomes y plus c for your y coordinate. So if you're adding a negative, then your y coordinate is going to become less, and if you're subtracting, your y coordinate will become more. Okay, so there's one last one. It should be National 5, but quite often it's kind of not covered, so we'll go on to that one next. Okay, so far what we've done is we've stretched our graphs horizontally, we've stretched them vertically, we've moved them up and down, so last and not least is moving it left or right. So I've got the original sine graph there, and so that's still y equals sine x, and what we can do is our graph, what happens is we can move it either left or right. So here, instead of starting at 0, I'm going to start at, say, minus 90. So I'm going to start at minus 90, go up, go back, go down, and go up. So at this point, that's going to be 0, that one's going to be 90, that is going to be 180, and then we've got 270 here, and the graph still keeps going because it's a wave, it keeps going. Okay, so what's happened here, and how we would say this one, is this graph would be the graph of y equals sine, and it's going to be x plus 90. Because we've moved it 90 degrees, and this is where things get a little bit unintuitive. Okay, so what we've got here, if we have y equals f of x plus d, just another constant there, it's not a specific constant or anything, what happens? So if we have f of x plus d. What we do is we move the graph d units to the left. So it's plus, it moves it to the left, which is the opposite of, in our heads, what we tend to think. Because on a number line, which we've been using since primary, positive is up, negative is down. So it's the opposite of kind of what we think for this one. So we have f of x minus d. Then what happens is we move the graph d units to the right. Okay, so it moves to the right. Okay, so what happens is, for this, for if we've got an x and we've got a y, what happens to them? The x, if it's plus, you take away, or if you're subtracting, then you add, and your y coordinate just stays the same. So, we've got those four things. So, with a graph, to transform it, we can move it up or down, we can stretch it, or we can compress it, and we can do it either way. Okay? But we've got those four things, but they tend to not happen on their own. We tend to have to combine them all. Very quickly, there is actually one last option that we've got, which is where we have a sine graph that looks like that. So it's still got 1 at the top, it's still got minus 1 at the bottom. But what's happened is everything is flipped, like it's flipped around the x-axis. And when this happens, it's y equals negative sine x. So that, again, works for any function. So if you've got y equals the negative function of x, what happens is the graph is flipped in the x-axis. So the coordinates, your x and y, what happens is that your x coordinate stays the same, but your y coordinate becomes the negative of it, so it's just flipped it in that axis. Right, so let's go on for an example. Right, so we've got a graph here. It is a cubic function, and we've got a certain number of points kind of written on the graph. And what you'll be asked to do is to sketch y equals something, and in this case I'm going to go for 2f of x minus 1. Okay? So, we know that the 2 out the front, this 2 here, means that our amplitude is doubled. So, for all of our points on our graph, so we've got 1, 2, we've got 2, 0, we've got 4, minus 2, and we've got 6, 0. So we know that what that 2 does is that doubles our y coordinates. So we're going to have 1, 4, we're going to have 2, 0, because 0 can't double to anything. We're going to have 4, minus 4, because the minus 2 is doubled, and then 6, 0. Okay, so then the next thing that happens is the minus 1. What that does is that moves our graph one place to the right. Okay, so that's our x coordinate. We have to add 1 to our x coordinate. So we get 2, 4, 3, 0, 5, minus 4, and 7, 0. So we can then sketch our graph. The important thing when you're sketching these is if they've given you points on the graph, oh, we've got another point on our graph. We have 0, 0, which is now going to be at, stays at 0, 0 for this first one, and then will become 1, 0.
So all the points that they've given you on the graph where you know the exact point and where it crosses the axis, or they've given you the coordinate, those need to be on your graph when you sketch it. So normally, what I do actually, don't know why I do that in the first place, when I sketch a graph, is what I do is I draw the shape that we need. So that's the rough shape we need, and that's y equals 2f of x minus 1. And then I go through and I put my coordinates in after. So here we know our x-axis has got to be somewhere around here. So that's our x-axis. And then we can mark these points. We know that's got to be at 1, that one's at 3, and this one's at 7. We know this one here is at 5 minus 4. And we know that this one here is at 2, 4. And then from where those things are, we can know that our y-axis is going to have to be somewhere around here, and we have sketched our graph. So the important thing is to the points that you've got, you move them. Okay? Right, I'll do one more example. I'll use the same function, but we'll do a bit more complex. Right, so this time, we're going to sketch y equals negative f of 2x plus 2 minus 1. Okay, so this has got quite a few things that we're going to have to think about. So we've still got our same points. We've got 0, 0. We've got 1, 2. We've got 2, 0. We've got 4 minus 2. And we've got 6, 0. Okay, so it's figuring out what happens to these. We can do it kind of step at a time. That's not a problem. So the first thing is negative at the front, so everything becomes negative. Well, the x-coordinate stays the same, the y-coordinate becomes negative. So we've flipped our graph so it's up the other way. Right, okay, so the next kind of easy bit to deal with is this minus 1 here. So we know that that minus 1 means that the whole graph is going to be moved down 1 point. So we can do that with our coordinates. So that means that our y values have been reduced by 1. So it becomes 0 minus 1. We're going to get 1 minus 3. We're going to get 2 minus 1. We're going to get 4, 1. And we're going to get 6 minus 1. So far we've dealt with this part, the negative, and we've dealt with the minus 1. And then in our function bit, we've got 2x plus 2, and this is where it becomes a little bit more complex. So, because we've got a combination, we know that the 2x is going to make the graph compressed, so it's going to make it half as big, and then the plus 2 is going to move the graph. But the 2x, because it's all in there together, it does actually affect how many units it gets moved. So you can kind of think of it as 2 times x plus 1. So the 2 compresses it by half, but then we're only actually going to move it 1 unit over. Okay, so if we compress it by half, our x coordinates become half as big. So our 0 just stays at 0, and when we get minus 1, our 1 will become a half, and then we've got minus 3. Our 2 will become 1 when we half it, and then we've got our minus 1. Our 4 will become 2 when we half it, and our 6 will become 3 when we half it. Okay, and then we've got to move it plus 1, so that's moving it to the left. We've got to move it to the left 1, so our x coordinates are all going to have 1 less. So we've got minus 1, minus 1. We're going to have minus a half when we take 1 away, minus 3. We're going to have 0, minus 1. We're going to have 1, 1. And we're going to have 2, minus 1. Okay, so that's our final thing. We've done all 5 steps we need to do. It can take quite a lot for doing these. The more you do them, the more likely you are to just be able to kind of do it all in one go and kind of figure it out. or you could do each step like that, like I've done there, showing how the coordinates change each time. So we know that the graph is going to be the other way up, so it's going to look like that. It's not so good. Let's try again. Nothing wrong with trying again. So it's going to go down a little bit, up a lot, and then down that way. That's not too bad. I'm just going to fix this a little bit here. Right. Okay. So our first point, which was 0, 0, has now become -1, -1. So we have -1, -1. Our next point, which was 1, 2, has become -0.5, -3. Our next point has become 0, -1. So that's -1. So we know that that is where our x-axis has got to go. Where our y-axis has got to go even, because it's 0 on the x-axis, so that's there, and our -1, so that means that's going to have to go about there, our x and our y. Okay, and then we've got up to here, which is 1, 1, and then we've got 2, -1. Okay, so it's just going through it systematically, step by step, and changing all the coordinates by all the things we need to. Sorry this has been quite a long video, but there's quite a lot to cover for this one. Okay, and it'll be quite a lot of just practicing these before we move on to the next thing, okay?